Alright, today on my bench I have a Realistic Pro 2004 300 channel scanner. I bought this on eBay. Let's see here, I'll go through what the eBay ad said. Realistic Pro 2004, no antenna for parts repair. This scanner is working, but you will need to replace the LM light and the squelch problem. I don't know what the LM light is. When it is power on, the scanner starts to scan and doesn't stop. I paid $8 for shipping to have this brought to my house, and I'm going to do a repair. And there's actually some good modifications you can do to this. We'll go through that in a bit. I just want to go over the specs. This thing is a 1986-1988 era scanner. It's long discontinued many decades ago, but they only kept going for 2 years. The one thing I don't like about this is it has the membrane keypad, which is pretty cheesy in my opinion. They could have done something better than that, especially when you're paying $500-600. I think it was brand new back in the day. They were pretty expensive units, and to have one is quite a treat. But let's go through some specs here. That goes from 25 to 520 megahertz, and the first band, and then the next band it goes 760 to 1300 megahertz, and then it's blocked for cellular, the cellular frequencies, the analog cellular frequencies that we don't use any longer. They were blocked, so you couldn't monitor cellular calls, but there's a way around that. 300 channels in 10 banks of 30, and from what I understand there's a way to open this up so that you have 400 channels of programmable frequencies you can enter. 16 or 8 channels per second scan frequency. Has a 9-volt battery backup for your memory, backup memory, and this thing also works on 12 volts. You can plug 12 volts in here from your car. You can mount this thing in your vehicle and supply it with 12 volts from your vehicle, plus 13.5 or whatever it says here. Yeah. It's got a provision for an external speaker, line output for recording or whatever, amplification. It's got your BNC antenna input, and then it has a 0 dB or 10 dB attenuation at the beginning to knock down any strong signals. And like I said, it's got a battery cover here for the 9-volt battery, and there's no battery in there. That's a good sign. I was expecting to see a crusty mess. Anyways, okay, so let's power it up and see what it does. I don't have an antenna obviously, but it's plugged in. Well, the scanner does stop when the squelch, maybe the squelch was a loose wire or something, because it does scan when it's squelched. Battery indicators flashing. That's going to nag a person to death unless you put a battery in there. And that horrendous beeping. We have no backlight. It's supposed to be luminescent display, so I don't know if I can repair that or if we can substitute in some LEDs to backlight this, but that's not working. I don't know what this thing does. Sound squelch. Don't know. Program. Seems to work. No, I got no Let's hook up an antenna and see what kind of signals we can pick. So I just got a BNC antenna, so nothing. Just apply this to the back. Just start this thing to scan. Okay, while it's scanning, I'm just going to go through a few other things here. There's a few modifications we can do while we have it open. The extended coverage, what this does is it unblocks the factory block they put in on the cellular band, the 800, 900 megahertz cellular band. There's a 400 channel and speed modification. We can open this up to provide 400 channels instead of 300, and we can now scan at a higher rate of speed of 20 channels per second instead of 16. And then there's a squelch modification that we can do. So I think we'll probably do some of those if they're not done already. But this display looks like somebody might have been in here already. It's all kind of messed up. And the LCD is messed up on the top left corner. Thankfully it's still working, but I would never be able to find a replacement LCD. So we're already at 30 megahertz. I haven't picked up a damn thing. I'm going to just let it run for a while and then see if we get some signals. So I'm scanning through the FM band here, and it's picking up stations. It's having troubles picking up a lot of local stations. I don't know why that is. Oh, okay, I think it's got 3 modes: AM, narrow FM, and wide FM. It should be picking up stations, but it's not. So maybe there's something wrong with the tuner. Anyways, let's shut this off and open her up. Judging from all the smoke and dust, I would say it's been left on for quite a few hours. And the scratches here suggest that it's been opened a few times too. Fingerprints inside. Yeah, I think we're not the first ones in here. Let's take this front panel off and see if I can figure out what's going on with that backlight. Okay, so I got this disconnected. Take the speaker off. I'll take the speaker off just to get out of the way. Red goes there, black goes here, and this one and this one. There's 2 ground wires soldered to the main PCB. 28th of January 2020. I think that's about the time I bought this thing. Interesting. Now you see what I mean by having a messed up LCD? And this is dislocated too. And we have 2 disconnected wires from the luminescent panel. I wonder why. Well, let's see if we can get that working first. Let's solder this back together. I know I have luminescent panels kicking around here, but I don't think I have one that big. Before I put power to it, I just want to check this transistor. Emitter collector base, emitter collector base. Transistor's good. Oh, let's start with 9 volts. Oh, look at that. It's working. I have no idea why it was disconnected. There. So what I'm going to do, I'm going to change this electrolytic capacitor here. It's a 100 microfarad, 16 volt. It's just a little bit over limit on ESR. So I'm just going to change it and put another capacitor in before I put the new, just that it's going to cause me problems in the future. So I'll put this one in. So what I'm going to do is lay it down with just a dab of hot glue. To hold it there. Okay, so I got this back installed. Looks good. Display looks a lot better than it was before. Doesn't have that mung in the top there and no foam gasket in the way. So what I'm going to do is put this aside. And I'm looking at this here. Maybe I'm going to zoom in on it. Maybe you can see too. Look at the base of that capacitor. You see how it's... I think it's leaking. This capacitor is leaking. And if not, well, I got to clean this up anyways. I don't know if that's glue or if that's... It looks like corrosion to me. I'm scraping it and it looks like corrosion. So I'll take it apart and give me a chance to ESR these caps too to make sure they're all good. Alright. This aside. You can see there's a fair bit of heat going on here, and that is directly below. Here's a resistor, a dropping resistor, and the bridge rectifier. The two regulators keep the heat off the board, but still there's a little bit of localized heating here. 1000 microfarad capacitor. I just want to see some of the ESR on some of these. can't see that. I'll stand it up. Okay, so it's zeroed. Good. That is supposed to be a 47 microfarad 16 volt. So it should be below 1.6, not 10. And then I got a 100 microfarad 16 volt. 2.1. That one should be below 0.7. So I got two there, bad right off the bat. 470, 25 volt. Right here. Should be half that value. Should be 0.12. 1000 microfarad, 25 volt. That one seems okay. It's just on the borderline. 1.3, that is a 220 at 16. So that should be 0.3, not 1.3. Yeah, and then the big one, where is the big one? The 200 or 2200 microfarad is at 0.7, which is probably right on the border of being defective. So we have some old caps in here. So I have a feeling I'm going to replace all these caps. Let's pull this one out and check underneath it. Doesn't look like it's been leaking. All that corrosion is from the glue. Let's see how it's taking the solder mask off. That's better than what I thought. Okay, that's not that bad. Alright, so let's get some new caps in there and get this assembled again. Alright, so I got this portion power supply and I guess this is an audio amplifier here. This portion recapped. This is where all the heat was. This is where the worst caps were. I checked a few of these other ones. They're acceptable. So I'm happy with that. Let's put it back together. I checked for cold solder joints, but this is a double-sided board. Okay, so I'm going to move on to some of the mods I was going to make on this. I was checking to make sure they weren't done already, but the squelch mod is what they tell you to do. There's a resistor here. You can see that. 148, R148. There's a little resistor here. It's a 1/8 ohm 47K. They tell you to cut it and put a 100K resistor in series with this. So what I'm going to do is I'm just going to remove that resistor and put 150K ohm in, and we'll be done with that. So I'll try that now. There, got it out. And I have 150. You see that? Little tiny resistor, 150K ohms. Okay, so I soldered in the 150K resistor at location R148. right beside this integrated circuit IC number 2. And you can see the resistor in there. Other side. It was kind of tight quarters here for solder. I'm going to clean this up after, but it's got to be careful you don't have any solder bridges. Now on to the next modification. I'm kind of doing this backwards, by the way. Is the 400 channel modification and speed modification. So what they say is you want at the top of the sub-circuit board, locate the slot for D513. So diode 513 is right here. There's an empty slot for a diode. And then what they want you to do is count backwards until you get to a space for 510. So from 513, yeah, let's do this. 513's here. 12, 11, 10. The 10 is this spot here, these two holes. You put a diode in there, same orientation as what's shown on the board here. So I'm going to do that. And then the next one, the speed modification, is this one speeds up the scan. Okay, now install a diode at D514. So if I look here, right between 515, 513, there's an empty space. I'm going to put a diode in there, same orientation as the other two. All this does is it sets up the logic for a different configuration. One way you can tell is if you have the holes clear, you can see light through them. See how I got light through all 4 of them? Holes are clear. So we can stick our diodes in there and solder them back in. Okay, I got my 2 diodes selected. I just want to make sure that these are used diodes, so I just want to make sure that they're 100% working. That one's good. And that one's good. This one's a IN4148, and that's like a garden variety diode, switching diode. So, put this in now. Let's see. I was watching a YouTube video on the scanner from another YouTuber, and he did a complete going through, and he had nothing but nightmares with the boards. Apparently, the vias on these boards are supposed to be plated through holes, and he had nothing but problems with open circuit connections and cracked solder joints, and you name it, he had problems. And he poured through it and pushed through it and got through the thing, got it all working. And I really feel for him, because that's a lot of work. If I look at the number of vias on these boards, I could just imagine there's probably hundreds of them, and yeah, it's a real pain, but he pushed through. And then I'm looking at this scanner. Here, I'll show you right now. Read this tag. It says molded in the bottom here. Molded date, 4th month of 1988. So this is a very late model scanner, produced towards the end of its run. And these boards look entirely different from the ones he had on his video. Like they looked like a different process or a different, maybe a different manufacturer altogether, but they don't look anything like the ones he had. So I'm wondering if maybe this thing has some of that problem too. I hope not, because it'd be a big pain. But two other things. I checked these two capacitors, electrolytics. So one's a 10 microfarad, one's a 4.7. They're both good. And looking at these connectors, these plug-in connectors, I got cracked solder joints on a number of these. So I'm going to go through and I'm going to resolder all of these connectors. I checked the chips, everything looked good. And I'll go through and I'll check a few other components. But other than that, this board looks like it's ready to go. I think I still have one more mod. Oh, I forgot to show you what it looks like when it's done. Here. So there's a diode installed in the top position there, 510, 510, and then I put a diode in the 514 position. You see that? You can see that. So the last modification to this scanner is the expanded coverage, which opens up the 800 megahertz band for viewing, listening to channels, 800 megahertz to 900 megahertz. The old analog cellular bands. And it says to go in here and remove diode 513. So if I go in here and look, there is no diode in here at 513. It's been removed already by a previous owner. So that modification has already been done, and I don't have to do it. So I have the 400 channel mod, and I have the speed mod installed. So I think we're done with this. I'm just going to solder up the back, the connections, and then I'm done with this board. I'll put it all back together. Okay, I think I'm done with this. I worked through and resoldered all these connector pins. Some of them were cracked. Installed the two diodes. Did not remove the one that was already removed, so I'm pretty much done here. Check the capacitors. Now, if you do think you run into a situation where these vias are causing you a problem, these are plated through on my board. I can see with a magnifying glass these holes are plated through. But I suspect the earlier versions of these boards didn't have plated through holes, maybe, I don't know. And they were relying on solder to wake up and make the connection, which would explain why the guy that had the YouTube video had numerous failures on all these boards with regards to these vias. But if you suspect that you have problems with your vias, I think what you could do, easy enough, is take a single strand wire. Like this is a solid core wire. I don't know what gauge this is. This is a wire wrap wire. It's very thin. Strip this and use a little chunk of wire on each of these vias to bridge the connection from one side to the other. Solder it and trim it so there's nothing hanging over. And you'd have to go through and do all of these vias. I don't know. I bet you there's probably 30 or 40 here I can see. Just looking on the one side. Yeah, there's not too many. There's like 10 here, another 10 here, a few over here. There's a few up top here, but you get the idea. You have to get in there and bridge those connections to make the electrical contact, and it should bring things back to life. Also, you'll notice that some of these holes aren't plated through. Like for example, L503, L502, one side is plated through where it has a connection on both sides of the board. The other side is not plated through where it has a connection only on one side of the board, if you look. Now these solder joints that are only on one side, these are the ones that are prone to crack. Ones that have connections on both sides of the board don't crack as often, or as they usually don't, because they're a stronger joint and they don't have that flexing, mechanical stress and thermal stress. So yeah, I'm going to put this back together and move on to the next port. So I removed this board just to have a squint on the bottom, just to make sure I'm not having anything missed as far as cracked solder joints. I'm not seeing anything. It's pretty much shielded. I don't want to start taking shields off. That could be a pain. But I just wanted to check this board over and make sure it's 100% before I get back to... Oh yeah, lots of wax. Here's a capacitor in here. I checked this capacitor. This is the input power. If you look here, input power comes in, goes through a choke, goes through a little choke, and then on the other side of the choke there's a filter capacitor. So it's kind of like an LC network to clean up the power coming in. This capacitor is beyond the ESR limit, so I'm going to change it. This one here, I can't, unless I pull that shield off, I'm not going to be checking it. But let's check these other ones here. Maybe there's... So it's just RF transistors and amplification, oscillators, a couple of caps here. They're all wax encased. I'm not going to bother with this. I don't want to mess up any of the calibration or alignment here. 10 megahertz oscillator. So I'll change that one cap. And then I'll close this up. It doesn't look like I can do too much to it. It doesn't look like it needs any work. Okay, I've gone through and checked all the connections with a magnifying lens. And I did find some that look questionable, and I touched them up. Oh, there's another one. And I touched them up with solder just to make sure that there's no cracked solder joints that I can see. I didn't find too many on this board. I found most of them on the CPU board. But this all looks good now. So what I'm going to do is reassemble and start going into testing and alignment. I did want to mention one thing. When the unit came to me, the previous owner said the squelch wasn't working. And when I first tried it, he was right. It wasn't working at all. I could put it to 0 and it would still continue scanning. And then after a while it started working again. When I would turn it up to about 2, from between 0 and 2 you'd hear the hash, and then when it got above 2 it'd squelch out. Then it started working. But I looked at the connections here. They're all good. And I followed this cable to where it plugs in on the main board. Where is it here? This is the back side. Okay, so if I have it like this, plugged in, where it meets up is on one of these connectors here. Connector 5 I found had cracked joints on it, so I resoldered that one. Connector 1, I'm going to resolder all of these. Connector 2, 4, 1, and there's 3 over here. They seem to be, there's another one, 6. 6 is a little hidden over here. So I'm going to resolder those as well, just to make sure that there's no problem with it, because it did come back after. So I'll just do that now. Okay, so I'm just going to assemble this, and then we'll work on testing and alignment. Okay, I'll finish the screws and put the front panel back on, then we'll try it out. Okay, so when I test it out, I still have no backlight, and I was trying to figure out why. I did some measuring here. There's two modes, one with the dimmer on, one with the dimmer off. So I'll check with the dimmer on first, and I'll show you what kind of voltage I'm getting here. Where can you see this? So with the dimmer on, I'm measuring about 3 volts to that inverter. Turn the dimmer off, and I'm getting 4.5. Now that's just not enough for that luminescent display. I guess that display is aged to the point where it doesn't illuminate anymore. I put 9 volts to it, it came alive, but that was because I was over voltaging the inverter. And just to give you an idea of what kind of voltage the display needs, this is set to AC volts. And I'm getting about 88 volts AC on the output of that inverter to light that luminescent display. Now there's one or two things I could do. I could increase the voltage to that inverter, but that would only accelerate its demise kind of thing. Plus this logic board here that's behind the panel is fed with 5 volts, so that's all they're feeding the inverter with is the plus 5 volts. I have to run a separate line to this to get it to a higher voltage, and I'm contemplating doing that, but then I'm not sure yet. I might do a LED conversion on either way. But if we check it out, we do have an additional 100 channels of scanning and programming, and see there we're into the 300 to 400 channel range, and it drops down to 0 again. So Welch is working. I'm just going to go through the checks just to make sure everything's 100%. And then I'm going to work on the alignment and go through that just to make sure it's working. Okay, what I want to do here is I want to deal with this electroluminescent panel that's not working. I had a few options. I was looking online, and you can buy electroluminescent panels that are actually larger than what you need, and you can cut them down with scissors. I'm not a big fan of that. I have a kind of a feeling that it shortens their life when you start cutting them up like that, and then but maybe I'm wrong, I don't know. But this panel is kind of a unique size. Let's pull it out and see what I got. I got a few panels here that I salvaged from other pieces of equipment. Pull it out. Now you can see whatever panel we have to put in there has to cover up the LCD viewing area, because we're going to see in behind there, right? And this fits in there perfectly. A few other panels I have. This one here is probably the most acceptable one, just because it's the same length. But if I shove this in, you're going to see why that doesn't work too good. So what I'm going to do is I think I'm just going to cut a piece of paper this dimension and put that on top of the panel underneath the LCD display, and that'll diffuse the light, and it will also block out all that stuff we're seeing in the background there. So let's try that. So I'm just going to use regular photocopy paper and I'm just going to cut it to the same dimensions as the old panel. Just like that. And then I need to, so yeah, let's just get this the right size. We've got our blank paper. This might be hard to get in. You got a little too wide, maybe. Let's try trimming it a bit. All right. Yeah, that's better. Doesn't want to cooperate. Paper's not very friendly. There we go. There we go. Okay. So that's going to be the background for the LCD. This one goes in. Okay. The panel's in. I'm going to try powering this up, see how it looks. One thing I tried is I tried mucking around with the resistance values here for the dimmer switch. They had some resistors in series to drop the supply voltage to this little driver transistor. And what I did is I mucked around with the values of those resistors to boost the voltage and current going to this driver circuit, which in turn helped the display work on the bad luminescent panel, but that was short-lived. Like, it was in a matter of hours that little bit of gain I made, it disappeared. So okay, so let's install that back in the radio and see how it works. Alright, I got it back together, enough just to test it, plug it in, and hopefully we get some acceptable. Turn this off. And it's lit up. So you can see that there's a dark band on the bottom where the electroluminescent panel is not covering. It's actually a little higher, but it still works. There's nothing down there that is needing light. Works fine. You can see that darkness and light. Okay, I'm going to call that a fix. Put it back together. Okay, just a little update what I'm finding here. I put it all back together and I started to do the alignment testing and ran into another problem. The squelch circuit works when it wants to work. Doesn't work when it doesn't want to work. There's no rhyme or reason to it. Sometimes it works, like it is now. Sometimes it doesn't work. It just keeps scanning and scanning and scanning, even though the squelch is turned down. So I broke out the schematics. I broke out the voltmeter. And what I found is when the circuit's not working properly, this chip here, IC2, which is a FM intermediate frequency chip, with a squelch circuit built into it. Pin 4, normally pin 4 has about 7.5 volts on it to power the chip. But when the chip when this stops working, the voltage drops to about 3.5 volts, which is below the threshold for this chip to operate. It needs between 4 volts and 10 volts. It's a low current chip. It drains maybe 2.5 to 4 milliamps when it's in operation. So I found that when the squelch circuit's not working, this voltage on pin 4 drops to about 3.5 volts. And there's no rhyme or reason to it, because this is a 8-volt power rail that's supplying this chip. Now there is a 100 ohm resistor between the voltage regulator transistor and the chip itself. If I follow the power rail, it goes up and around and down and back and then goes up into here. And there is a 100 ohm resistor here, but I haven't been able to recreate the fault to test if I'm losing that 4.5 odd volts voltage drop on this resistor, or if it's somewhere on this line that it's making a flaky connection. I happen to think it's on the line somewhere, because when I touched one of the vias with my probe, it came back to life. So I'm gonna take, yeah, it's actually right down here where it touched. So I have to pull this board out one more time, and I think I'm going to solder the wires through the vias just to make sure that there's no faults on the B plus line heading to the circuitry. Okay, I went through the alignment, and it went okay. I had a few things that confused me about some of the bands. It seemed like some of the bands I couldn't adjust, or they weren't adjusting properly. So what I did is I went through and I checked with my signal generator each band individually, and I'm getting sensitivity down to 1 microvolt on my signal generator. That's as low as it goes, and this is picking up 1 microvolt signal. I don't know what the spec is for these. I should have looked, but everything's good. I'm at the maximum of my signal generator, which is 1.05 gigahertz, and I'm at 1 microvolt, and it's picking up the signal. I turn it to 2 megavolts, 3, 4, 5. So it's there, the signal's there, and it's picking it up. So as far as I know, I have a runner here. Everything's working now. The squelch is working properly. I talked to the previous owner by email, and I asked him out of curiosity, I says, why was the luminescent display disconnected? And he wrote me back and he says, well, he did have a replacement panel, luminescent panel for this, and he installed it, and he was running the scanner, and from what I can tell, the squelch problem made him abandon this receiver. And he took the panel out, the new one, and put the old one back in, so that he could use that new LCD luminescent panel in his other scanner. I think it's a Pro 21 or something, 2021, 22, I don't know. But that makes sense to me. So I guess he just gave up on this because of that squelch problem. But it seems like I have that under control now. And it seems to work fine now. I'm going to have it sit on my bench for a while here. I'm just going to play around with some music. I'm going to play around with it on my bench here and see what kind of reception it gets. So I'm on the home stretch here, putting everything back together, and then I've bundled it up and I got no audio. Isn't that how it goes? Oh, look at this. I'll have to take the board out one more time. Bear with me. Alright, one last time. I got it all back together. And it is working this time. Like I said, I'm going to try this out for a while and see how it performs. Thanks for watching.